to talk about light. Now, there is a lot to talk about when we talk about light. So, what I'm going to do in this video is, because there's so much and the topics are very, very different, is there's going to be a big heading graphic for each of the topics that we're going to kind of go through. Okay? So, there's going to be one that's going to pop up right now, and it's going to say visible light. All right, so the first thing we need to talk about when we're talking about light is something called the electromagnetic spectrum. Now, that sounds like a really big, fancy word, all right? And it kind of is. And what it deals with is it deals with radiation, electromagnetic radiation that's given off. Now, typically when we're talking about this, we're talking about it being given off from stars or from our sun. And it's this huge, wide variety of different kinds of energy waves or radiation waves that are given off. And some of them you've probably heard before, things like infrared or ultraviolet or radio waves, or if you're a fan of the Fantastic Four or the Hulk, gamma rays. If you've ever had a broken bone, X-rays. All those rays, all those waves, they're all on the electromagnetic spectrum. And so on this spectrum we have weaker waves, like radio waves, and then we have much stronger waves like gamma rays and X-rays. Now, the gamma rays and the X-rays, those stronger waves and the stronger rays, they're very harmful to humans because they're so high energy. So there's all kinds of things on the earth that protect us from them. Now, we're not going to get into that in this video, but if you want to look into it, it's some really, really cool stuff. The part we're going to talk about on the spectrum is the visible light section, and it's actually pretty small. I mean, you're probably looking at the screen right now going, hey, look at all that stuff, and there should be an itty bitty 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 section where we see some colors and we see visible light. And visible light is actually a combination of several other different kind of lights all overlapping one another. So we start, before we get to visible light, with infrared. Hint, hint, wink, wink, the color red. And then we end, on the other side of visible light, with ultraviolet. That's not a coincidence. So if we think about our Roy G. Biv, our rainbow colors acronym, and we've got red, orange, yellow, green, blue, indigo, and violet, we start with red, we end with violet. Well, before red there's infrared, and after ultraviolet, or after violet, there's ultraviolet. That's not a coincidence. So though that's the part of the electromagnetic spectrum that we can see with our eyes. Now, another fun fact, and something you can look up on your own if you want to, is there are some animals that can actually see into the infrared part of the EM spectrum. EM is short for electromagnetic. And there's some animals, some birds specifically, that can see into the ultraviolet part of the EM spectrum. So pretty cool. We can't see in those, but they can. All right. So what I want to talk to you first, though, about is this idea of color. Now, we just said that visible light, sometimes you'll hear it called white light, is composed of all these other different kinds of colors, all these other different colored lights, and they're all overlapping on top of one another. So they're just kind of running together. All right. And so when we see light shining down on us, that's all those different kinds of colored light is what we're seeing. When they hit something, though, something really interesting happens. So I've got some different colored papers here, and they're just some basic colors off of our Roy G. Biv. So the first one is red. So when we see the color red, let's put these others aside for a second. When we see the color red, what's happening? Well, what's happening is the white light shining down from the lights that are just above me, that white light, that visible light, is coming down and it's hitting this paper. Now, this is what's interesting, and this is what's real hard for people to kind of wrap their brains around, is the other colors, orange, yellow, green, blue, indigo, violet, they are all absorbed by this paper, while the red is reflected. So I see the red because it's what's bouncing off. And we're going to talk about reflection a little bit later in more detail. But the red color is what's bouncing off so that I can see it. So when I see these different colors, I'm seeing the blue light, the green light, the yellow light, the red light, from the visible light, from the white light, hitting and then bouncing off. Everything else is absorbed, but I see that one color. Well, Mr. Beckwith, what about colors like salmon and fuchsia and all these other kind of different colors, beige and taupe and all these weird colors, I don't even know what they are. Here's the deal. We actually see combinations of colors. So just for fun, again, if you go into Paint or sometimes into the font of a word processor or something like that, on your computer, and you click on the color, you've got this huge palette where you can pick all these different color types. But if you'll notice, you'll see those base colors from the rainbow, from the EM spectrum for visible light. You'll see those base colors in there, and then what you're seeing is mixtures of those different colors. All right? So that's just a little bit on color. And again, it's a little bit confusing, so if you need to do a little bit extra on it and look at it a little bit more, then I would. Because just this whole idea of white light really being red light, and orange light, and yellow light, and green light, and blue light, and indigo light, and violet light, all sort of stacked on top of one another is a little bit strange. All right? The next thing we're going to talk about is a concept called transparency, or translucency, or opacity, or if I pronounce that right, but when something is opaque. So what these terms mean, and I've got a couple of little things to help me here. And these are very just basic little containers, things that you might find in your kitchen or in your cabinet. Now, transparency, being transparent, you probably know what that is. It basically means, though, that light travels through an object. So I'm closing one eye, and I can clearly see the camera that is doing this video right now. Very obvious. So the light is passing through it. If I hold it up to the light above me, the light's passing through it and hitting me. All right? This is transparent because the light passes through it. When light passes through something, it is transparent. All right? Now, translucence is a little bit different because some light will pass through it, but not all. So when I hold this up, you can very clearly see a shadow coming over my face because not all the light is passing through, but there is some of it passing through. If I was to hold a flashlight to the back of this and shine through, you'd see some of the light coming through. This is translucent, which means some light's coming through, but not all. Whereas with transparent, pretty much all of it's coming out. Now it's a little bit shiny, so we've got a little bit of reflection going on in this particular cup. But for the most part, all the light's passing through it. And then the last thing we have is something that is opaque. Now something that's opaque is blocking all the light. So all the light is either being absorbed or reflected. It is not passing through. So if I hold this up, it's a lot more obvious that you see the shadow on my face because it's being blocked by the light. So transparency, translucency, and opacity or opaqueness, I don't know. I can't pronounce it. I can spell it, but I can't pronounce it.